whenever there is a relation between the element between A and B. Such types of subsets of Cartesian products are called as relations. Range is always a subset of codomain. Sometimes it is also equal to codomain. So that's why we write range as a subset of codomain. All the numbers in the set of integers are in relation here, whose image is also a set of integer. So therefore clearly we can say here the domain is the set of integers only. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Today in this session, we are going to learn about the relations. So what do you mean by this relations? So relations are the subsets of Cartesian product. We have learnt in the previous session that Cartesian product is the set which contains the elements in the form of ordered pair, where the first element belongs to the first set and the second element belongs to the second set. That is, we can define A cross B in such a way that it's a collection of all ordered pairs where A belongs to set A and B belongs to set B. So this is our Cartesian product. And coming to the number of elements in Cartesian product, suppose set A contains 2 elements, set B contains 3 elements, then number of elements in A cross B will be equal to 6. So that is, we know that how many subsets can be formed when the number of elements inside a set is given. Suppose A cross B contains 6 elements, then the number of subsets that can be formed is 2 to the power 6. Suppose A cross B contains 4 elements, then the number of subsets that can be formed is 2 power 4 element. And all those subsets of Cartesian product can be termed as a relation whenever there is a relation between the element between A and B. Such types of subsets of Cartesian products are called as relations. So thus usually R is a relation which is considered as a subset of a Cartesian product. That's why we symbolically write R is a subset of A cross B. Now how that subset is derived? That subset R, or that the relation set, is derived from the set A cross B by depicting or by describing a relation between the elements, first element as well as the second elements of A cross B. So we have an ordered pair in the form of A comma B. We will define a relation between A and B such that only those elements can be written in the form of an ordered pair in the relation set. That is why we call R as a subset of A cross B. And always the second element is called the image of the first element. We call, whenever I write 1 comma 2 here in terms of ordered pair in the relation set, we always say 2 is the image of 1. When I write 1 comma 3, we say 3 is the image of 1. So that is why the second element is called as the image of the first element. Now let us take an example to define a Cartesian product and why we call R as a subset of Cartesian product. So here I have taken an example. Let A is equal to ABC, B is equal to apple, ant, ball, cat, dog. Then A cross B has 15 ordered pairs. Why 15 ordered pairs? Because we need to pair A with all apple, ant, ball, cat, dog. Next B with all these 5 elements, C with all these 5 elements. So here we have 3 elements, here we have 5 elements. So total A cross B has 15 elements. So we have 15 elements in A cross B. Now, thus A cross B contains all the ordered pairs where the first element belongs to set A and the second element belongs to set B. Now, I will introduce a relation between set A and set B in such a way that A is the first letter of B. When I write the ordered pairs in the form of A comma B, I should write in such a way that the A, if I write A here, the second element should start with the first letter with A only. Then what are the elements I can pair from this A cross B? So we know that A cross B here will be in the form of A comma apple, A comma ant, A comma ball. Like that we can pair with each element. So similarly, when A is paired with all elements, next we will take with B comma apple, B comma ant, next we take B comma ball. Like that we will also pair with C. So in total there are 15 elements. But now I have defined a relation R where the ordered pair has to be chosen such that A is the first letter of B. So that means when you take the second element, the first letter should start with the first element. So therefore, the only elements I can choose is A comma apple, because you can see here A is the first letter of apple, A is the first letter of ant, B is the first letter of ball, C is the first letter of cat. So this is the relation between the elements in this relation. Okay, but the other elements are not considered in the relation set because there is no relation between the first as well as the second element. When I take A comma ball, here A is not the first letter of ball. When I take B comma ant, here B is not the first letter of ant. Thus, all these elements are already in Cartesian product and they are derived from the Cartesian product. Hence, relation is a subset of Cartesian product where we define a relation between the set A and B in such a way that the given condition applied in the relation set. Now, after writing this, the relation set, we have few more terms to be recognized. The first thing is domain. So when you write the relation set, in the relation set here, there are 4 ordered pairs. In all the ordered pairs, we have the first element. That is, what are the first elements we have here? That is A, B and C. And all these elements in the form of a set is called as domain. That is, the set of all first elements in the ordered pair of the relation set is called as domain. And the set of all second element. What are the second elements we have here? Apple, ant, ball and cat. So these apple, ant, ball, cat, they are the second elements in the ordered pair inside the relation. They are called as range. Next we have one more set that is called as codomain set. So codomain set is nothing but the second set inside the relation. When I say R is a relation from set A to set B, your second set, that is set B, is considered as the codomain. And after framing the relation or after forming the relation, the ordered pairs, in those ordered pair, the set of all first elements is called as domain, the set of all second elements is called as range. Thus we have domain is nothing but the set of all first elements in the relation R, range the set of all second element in the relation R, and codomain the complete second set in the relation. Say, when I say I am defining a relation from set X to set Y, then set Y is called as the codomain. So, from the above example, this is what the domain, range and codomain we have got. So, you can clearly set B contains apple, ant, ball, cat, dog. So, therefore, your codomain is the complete second set. Your range is the elements which are in relation in the second set. Your domain is the first elements which are inside the relation set. And also, you should observe that range is always a subset of codomain. Sometimes it is also equal to codomain. So that's why we write range is a subset of codomain. See here, the codomain set is apple, ant, ball, cat, dog. Range is apple, ant, ball, cat. So therefore, range is a subset of codomain here. Sometimes it might be equal to codomain also. So few more important things to note here is the relation set can be represented algebraically using the roster method or set builder method. As I said, your Cartesian product is a set and relation is also a set, or we call it as a subset of a Cartesian product, and we know that set can be represented in 2 forms. One is roster form and set builder form. Hence, the relation set can also be represented in roster form as well as by depicting the relation in the set builder form. One more representation we have is called the graphical representation of a relation using an arrow diagram. What is this arrow diagram? So, I have taken an example of set A and set B. Suppose set A contains the elements A, B, C, and set B contains the elements apple, ant, ball, cat, dog. So now I am defining a relation from set A to set B such that the first letter of the element inside the second set must be present in the domain set. So thus we have A related to apple, A related to ant, B related to ball, C related to cat. There are no element where the dog has the letter D in the domain set. Thus we call A, B, C as the domain, apple, ant, ball, cat as a range, and the complete set B, that is apple, ant, ball, cat, dog as the codomain. So this is the visual representation which called as an arrow diagram. So thus we can write the set in all these forms. Next, let A is equal to 1, 2, 3, 4, 5, 6. Define a relation R from A to A by R is equal to x comma y is equal to x plus 1. Depict this relation using an arrow diagram. Write down the domain, codomain, range of R. So here the condition is given. I need to define a relation from A to A itself. That means I have to take two sets here. I need to write this relation using an arrow diagram. So let me write all the elements in set A here. So I am defining relation from set A to A. So we have 6 elements, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. They have given a condition that how you should pair the elements here. The second element is the sum of the first element. Suppose you take x is equal to 1 there, then y is equal to 2. So therefore, the first element is 1, 2. So therefore, I need to pair 1 with 2. Because the first element is in the form of 1, 2. Next, I will take x is equal to 2, then it is 3. So the second element is 2, 3. The next element is 3, 4, 4, 5, 5, 6. And the next one, we will get 6, 7. We cannot take this because 7 is not inside set A. So thus, we have the relation 3 goes to 4, 4 goes to 5 and 5 to 6. So this is how we will write the relation with respect to arrow diagram. Now we need to find out the domain. So domain and range are the elements which are in relation in the first set and the second set. So clearly you can see what are the domain elements which are in relation. So the domain elements here are 1, 2, 3, 4, 5. Because they are in relation. 6 does not contain any image. So therefore, 6 does not comes under the set domain. Next, I will write range. What is the range here? So with all the images, the set of all images is a range. So that is 2, 3, 4, 5, 6. So these are all the range. What is codomain here? So codomain is the complete second set here. So your codomain is the set A only. It is equal to A only. That is 1, 2, 3, 4, 5, 6. So this is how we will write or we will define the relation with respect to arrow diagram. Now domain, range and codomain of the given relation is given. Let A is equal to 1, 2, B is equal to 3, 4. Find the number of relations from A to B. So, number of relations are nothing but number of subsets of A cross B. Why? Because relation is a subset of A cross B. So, how many number of subsets can be formed for A cross B? The same number of relations can also be performed for A cross B. So, that is why here we have A 2 elements and B contains 2 elements. So, number of elements in A cross B is equal to 2 into 2 is equal to 4. So thus, number of subsets in A cross B is equal to 2 power 4, that is equal to 16. So number of subsets is nothing but number of relations from A to B, is also 16. So why? Because we know that R is a subset of Cartesian product. So how many subsets can be formed for A cross B? The same number of relations can be formed from A to B. Next, let A is a set from 1, 2, 3 until 14. Define a relation R from A to A by R is equal to x comma y, 3x minus y is equal to 0, where x and y belongs to set A. Write down its domain, codomain and range. Now here we are taking the set A. So we have the elements from 1, 2, 3 until 14. So we have only elements from 1 to 14. We are supposed to define a relation from set A to set A itself. So therefore my codomain is also A only. Now how we have defined the relation here? In the form of x comma y. If you go on substituting the value of x from this set, y gets the value. So let's take the first value. Let me take x is equal to 1 here. Then what is y? But to find y, we have an equation here. What is that? 3x minus y is equal to 0. So if I get 3x minus y is equal to 0, I can write y is equal to 3x. So now I have taken x is equal to 1 there. What is y according to the equation? It is 3 into 1, 3. Next I'll take x is equal to 2. Then I'll get 3 2s are 6. X is equal to 3, 9. X is equal to 4, 12. X is equal to 5, 15. But I can't write this because 15 is not inside the set A. They have clearly mentioned x and y belongs to set A. But 15 is not inside the set. So therefore, I need to stop the set here only. Now I have written the relation set. Let us write down the domain. So what are the domain? Domain is the set of all first elements in the ordered pairs. What are the first elements we have? 1, 2, 3 and 4. Next we will write down range. What is the range of the given set? All the second elements, or we call it as the images. All the images, that is 3, 6, 9 and 12. Next, what is your codomain? Codomain is the complete second set. Because we are defining the relation from set A to A, your second set is also A. Therefore, the codomain is the set A. That is the elements from 1 to 14. A is equal to 1, 2, 3, 5. B is equal to 4, 6, 9. Define a relation R from A to B by R is the collection of ordered pairs in the form of x comma y. The difference between x and y is odd. X belongs to A, Y belongs to B. Write R in roster form. So how the relation set is defined here? Suppose if you take x from A and y from B, and if you take the difference between x and y, that should be odd. Now let me take 1 with 4. Can I write 1 comma 4? Yes, I can write, because the difference between 1 and 4 is 3, which is an odd number. Now, can I write 1 comma 6? Yes, I can write 1 comma 6 because the difference between 1 and 6 is 5. Next, I'll take 1 comma 9. I can't write 1 comma 9 because 1 and 9, the difference between 1 and 9 is 8, which is an even number. Hence, I cannot write the ordered pair 1 comma 9 inside the relation set. Next, I'll take 2 comma 4. 2 comma 4 is not possible. 2 comma 6 is not possible, but 2 comma 9 is possible because the difference is 7. Next, I'll take 3. 3 comma 4. Yes, I can write 3 comma 4. Next, I can write 3 comma 6, but I can't write 3 comma 9 because its difference is 6. I can write 5 comma 4. I can write 5 comma 6, but I can't take 5 comma 9. So this is the relation set here. So you can see here all the x belongs to the set A. 1, 2, 3, 5 belongs to set A and all y belongs to set B. That is 4, 6, 9 belongs to the set B here. So therefore the condition is satisfied and these are the elements in the given relation. So this is the roster form of describing the elements inside the relation set. Now coming to the domain, codomain. Domain is all the first elements, that is 1, 2, 3, 5. That means your set A is the domain and your set B is the range as well as the codomain. So next question, let A is equal to 1, 2, 3, 4, 6. Let R be the relation on A defined by A comma B such that AB belongs to A. B is exactly divisible by A. So since we are defining the relation from A to A only, both elements belongs to the same set. And how we need to pair the elements? We need to pair in the form of A comma B such that B is exactly divisible by A. Now first one, write R in roster form, find the domain of R, find the range of R here. So let me take the elements 1, 2, 3, 4, 6. 1, 2, 3, 4, 6. Now I need to pair the elements. So let me write the relation set R here. So now let us start pairing. So can I write 1 comma 1? Yes, because 1 is divisible by 1. So 1 comma 1. So 1 is divisible by 2. B should be divisible by A. So 1 is divisible by 2. Next I can write 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 6. Why? Because if I write 1 comma 2, 2 is divisible by 1. I can write 1 comma 3, 1 comma 4 and 1 comma 6 because you can see that second elements are divisible by 1. Next, can I write 2 comma 1? No, because 1 is not divisible by 2. So therefore here I'll take 2, 2. So I can write 2 comma 2 because 2 is divisible by 2. Now I can't write 2 comma 3. I can write 2 comma 4 because 4 is divisible by 2. So therefore I can write 2 comma 4. Next, I can take 2 comma 6. So therefore here we have an element 2 comma 6 because 6 is divisible by 2. Next is I can't write 3 comma 1, 3 comma 2. I can write 3 comma 3. So 3 comma 3 is possible. 3 comma 3 is possible. 3 comma 4 is not possible, but 3 comma 6 is possible because 6 is divisible by 3. Next I'll take 4. 4 comma 1, 4 comma 2, 4 comma 3 is not possible, but 4 comma 4 is possible. And 4 comma 6 is not possible because 6 is not divisible by 4 or 6 is not exactly divisible by 4. So 4 comma 4 is possible. Similarly, 6 comma 1, 6 comma 2, 6 comma 3, 6 comma 4 is not possible because all these numbers are not divisible by 6, but 6 comma 6 is possible. So therefore the last element is 6 comma 6. So these are the elements of the given relation set. Now let us find the domain of R. Domain is all the first elements in the ordered pairs. What are the first elements in the ordered pair here? 1, 2, 3, 4, 6. Now let us write the domain of R. So what is domain of R? Domain is the set of first elements in the ordered pairs. That is 1, 2, 3, 4, 6. So domain is 1, 2, 3, 4, 6. What is this? 1, 2, 3, 4, 6. It is your set A. So the domain of R here is set A only. Next, range of R. Range is again you have 1 as the image, 2 as the image, 3, 4 and 6. So your range is also 1, 2, 3, 4, 6. So that is equal to A. So here the domain is also A because all the elements are in relation. Your codomain is also A and your range is also A because all elements are the image of the first elements. Determine the domain and range of the relation R defined by R is equal to x comma x plus 5. X belongs to the set 0, 1, 2, 3, 4, 5. That means I need to take the value of x from 0 to 5 and let us write the second element. So R is, first let me take 0, then it is 0 comma 5. Next we have 1 comma 6, 2 comma 7, 3 comma 8, 4 comma 9, 5 comma 10. So now we need to find out the domain. So let's write the domain. What are the domain here? So domain is the set of all first elements on ordered pairs, that is 0, 1, 2, 3, 4 and 5. Next we have range. Range is all the images, that is 5, 6, 7, 8, 9, 10. So this is the range of the given relation. Next question. Write the relation R in the form of x comma x cube. X is a prime number less than 10. So what are the prime numbers less than 10? That is 2, 3, 5 and 7. Now I need to write the relation R. I need to write it in the form of x comma x cube. Suppose I take 2, it is 2 comma 2 cube, 3, 3 comma 3 cube, 5, 5 comma 5 cube, 7, 7 comma 7 cube. So therefore, here R is 2 comma 8, 3 comma 27, 5 comma 125 and 7 comma 343. So when they ask you the domain, domain is 2, 3, 5, 7. When they ask you range, it is 8, 27, 125 and 343. Next, let R be the relation on Z defined by R is equal to A comma B. A, B belongs to Z. A minus B is an integer. Find the domain and range of R. We know that Z is the set of all integer which contains 0, all positive and negative integers. I am defining the relation R from Z to Z only. That is set of integers to set of integer. Now I need to choose the numbers in the form of A comma B such that A minus B is again integer. It is again integer. Suppose I take 1 from this set and 2 from this set. If I write it as 1 comma 2, suppose I take 1 from Z and 2 from Z and write 1 comma 2, 1 minus 2. 1 minus 2 is again minus 1 which belongs to set integer. Suppose I take 7 from here and 7 from here. If I write 7 comma 7, then 7 minus 7 is 0 which is again an integer. Suppose I take minus 3 from this set and minus 7 from this set, then minus 3 minus of minus 7 plus 7 which is 4 belongs to integer again. So whatever elements I take from the set Z for A as well as B, and when I perform A minus B, the result gives you again an integer value. So that means what is the domain here? You are taking any elements from the set of integers. So that means you can take any value from the set of integer. So all the numbers in the set of integers are in relation here, whose image is also a set of integer. So therefore clearly we can say here the domain is the set of integers only and your range is also integer, whereas codomain is also integer. So therefore the complete set Z is the domain because we can choose any number from the first set, any number from the second set which is satisfying the condition that A minus B is an integer. Hence, all the elements inside the first set as well as the second set are in the relation. Therefore, our domain is the set Z, range is the set Z, codomain is also Z. So this is how we will define the relation under the Cartesian product with its domain, range and codomain. We'll meet you in the next session with the new concept. Until then, keep watching, keep learning, keep exploring. Thank you.